First, we will look at using a binary search tree to sort data. We will create a class that stores a first and last name and then use a binary search tree to sort these objects based on this class. Finally, we will code the binary search tree that we used. Here, we are using a binary search tree to sort string data. Here, we are using a binary search tree to sort integer data. We are creating a class whose objects will be sorted using the binary search tree. This is code that was already prepared. It adds names to the binary search tree. Create the class declarations in the header file. First, the node class. This is very important and is used to create the tree data structure. The left node pointer points to data that is less than the current node's data. The right node pointer points to data that is greater than the current node's data. The class binary search tree data members contains the base pointer for the tree and a count of the nodes as well as the current height of the tree, which is a measure of how deep or how many levels the nodes go. The copy tree method is used to make an exact copy of the tree for the assignment operator and copy constructor, while the add node and add array methods are used for balancing the tree. The tree is balanced when its height is the lowest that it can be. The search method returns true when the data is found. The forward and backward methods send the data to the client code in a forward and backward order, respectively. A node is a leaf when no other nodes branch from it. In other words, when the left and right pointers are not pointing to anything. This will hit the left nodes first, then send the current node's data to the client, then hit the right nodes last. You have to imagine this function traversing all the tree nodes from far left to far right and everywhere in between. This function does the same thing, just in the opposite order, right to left. This function is used by the balance operation, which fills an array with all the nodes and then adds them to a new tree. The balancing algorithm was implemented as a study of these data structures. It increases the efficiency of the binary search tree but is not very important. This is the copy constructor. This is the assignment operator. The copy tree method adds items to the tree in the exact order that they were added to the tree of the object being copied. This is because its job is to make an exact duplicate for the copy constructor and assignment operator. This binary search tree example does not allow duplicate entries. The add method places the data in its correct spot. If the data being added is less than the base tree node, then it looks to the left, otherwise it looks to the right, and keeps doing this until it runs out of nodes to compare its data with. This is when it has found where it will be placed. The add node method is used in balancing the tree, so it does not need to check for duplicate values and it does not need to allocate memory for a new node. In contrast to the add method, which add the data, this function adds an already existing node. The add array method is the meat of the balancing algorithm. It starts in the middle of the array and adds that node to the tree, then it calls itself with each array that is on the left and right of the middle as an argument to itself. This recursive method continues like this until it has reached all the nodes in the array and added them to the tree in a perfectly balanced order. This is the search method. If the data for the current node, named root here, is equal to the data being searched for, then return true. If the data being searched is less than the current node's data, then move on to the node on the left, otherwise, move on to the node on the right. The forward and backward functions, used by these methods, have already been covered. Find the leftmost node and you have found the smallest value in the tree. Find the rightmost node and you have found the greatest value in the tree. Like this video and subscribe to see more like it.